Welcome to another episode of Take It Easy. My name is Greg. Today I'm going to talk to Mark Potter from 3TI about 3TI and everything charging, and we're going to geek out presumably a little bit, so be warned. Tell us who you are, tell us who 3TI is and what you guys do.
Yeah, morning, Greg. 3TI stands for 3 Technology Infrastructure, and those technologies are solar energy storage, solar generation energy storage, and EV charging.
Okay, and there's a big canopy thing outside at virtually every fully charged show or everything electric show that I've ever been to lately. And, so is the idea to have solar, then battery in there? So if I remember correctly, you basically store some of the energy from solar and some of the excess energy from the grid, and then give that to people if they want to charge.
Yeah, and that's kind of the basis of the company, right? This virtuous trio of solar generation, storage, and EV charging. If you've got storage that supports EV charging, then you can use that storage to either offset the cost or time of electricity consumption from the grid. If you've got excess solar in the middle of the day, you can put that into the battery. And actually, when you're using batteries and EV charging, then you can reduce the amount of grid energy you need at kind of in terms of the infrastructure costs as well.
Obviously, you're not going to get all the energy to charge. How many cars can you put on those? Is it like 6 or 8?
Yeah, so the kind of two kind of key bits of our business are what we call the big solar car parks, which are like megawatt scale solar car parks, which I kind of say are 80% about generating solar power and 20% about charging cars underneath them. And most of that solar power goes into the sites they're at. So we do things like NHS hospitals, we do things like in big industrial plants and data centres, where we take 500 or 1,000 parking space car park, turn it over to solar generation, and use that to decarbonise the site that we're on. The product you're talking about at the moment, the one that's here at Everything Electric, is a bit more easier to move around than the big solar car parks. And that's a kind of a separate product line we started developing about 2 years ago. And that is a 12 charge point EV charging hub that has got around 20 kilowatt peak of solar on the top of it, a battery in at one end and kind of some magic in the other end.
Is it still grid tied, or is it like free from the grid?
Yeah, it's still grid tied. So the kind of Papilio products, where the big solar car parks are kind of 80% solar, 20% EV charging, the Papilio is more like 80% EV charging, 20% solar. So on a if you look at it as like an annual generation basis, depending on the utilization of the charge points, you could be getting anywhere between sort of 20 and 30, maybe even 40% of the total energy goes into EVs comes from the solar. Whereas obviously in a big solar car park, well, when those cars are charging underneath and you've got megawatts of power being generated off the roof, then most of the EV charging is solar.
And is this like a permanent structure that you put in, or is it just for events?
No, so events aren't really the right market. I know we bring them along here, as a showpiece, but really it's kind of a 2-3 year typical minimum period we'd expect one to be deployed for. Actually, we expect they'll stay there for some time after that, but it solves a particular problem. So if you take the big solar car parks, they can take sort of 18 months, 2 years from kind of initial introduction to breaking ground, and maybe another 6 months beyond that to get them actually generating energy. And the nature of that kind of big installation, those million pound installations, is that you need a long view for the future. So you need to look at returns in 4, 5, 8, 10, 15 years. And one of the challenges for a lot of businesses, first of all, if they've got smaller car parks, the economics don't work very well for small scale solar car parks. And secondly, a lot of businesses don't own the land that they're on. They're leasing, and they might have a 2 or 3 year lease left on the land that they've got. They want charging for their visitors or their guests or their employees. So what we have is a solution that doesn't have all the upfront costs, doesn't dig up the ground, doesn't need landlord support, or doesn't benefit the landlord ultimately if they move out. And generally speaking, I think there's a very high probability that when a new tenant moves into that building, or when that tenant moves to a new building, they're going to still want that solution. So, and if they don't, well, that's okay. We'll give it to the next customer.
Yeah. So that's why it's like is it semi-mobile for that reason, or is it just like convenience because shipping container gives you already a structure to put things in?
Yeah, so it's semi-mobile in that sense. So, it's not something you'd want to move for a weekend. It's not a Glastonbury kind of weekender, but it does make absolute sense if it's going to be in a place for several months or several years. It has some advantages in terms of planning requirements, installation time. It takes less than a day to get it installed and operating, and that gives that kind of rapid deployment. Doesn't have all the disruption, and also from an infrastructure cost perspective and from a project development cost perspective, there's big advantages as well. It's a lot of EV charging installations. Pretty much all of them are bespoke to each individual site, right? You have to go and work out where the trenches are going to go and work out where the distribution is going to go, and there's a lot of legal shenanigans that go with that. With Papilio, it's kind of a one-stop shop. It's an instant product in a box. You put it down, plug it in, turn it on, and it's ready to go. And it just does what it does. And you haven't got all that site-specific complexity. So it's a one size fits all, if you like.
Is the 3TI solution that's just type 2, right? Or do you have a CCS charging there as well?
So the product we've got outside is what we call the AC Fast Hub. That's the 12, 22 kilowatt type 2 AC chargers. We're working on a project right now with DESNZ and Innovate UK and some part of a UK consortium to develop a bidirectional charging version of that based on a DC microgrid.
That sounds great.
It's kind of exciting. Yeah, I'm very excited.
Well, I'm sure it's a subject for future episodes when it's out and, you can talk about it fully. But every time I stand outside the 3TI stand and the demo sort of thing, I see either people asking questions about solar, like I mentioned, which we both done like the 100%. I'll put solar on the roof when it's giving me 100% energy, and I faint basically when I hear that. Or they say, oh, what is this? Like, this looks like, like a makeshift car park. And I'm like, it's quite a clever solution, but I wanted you to explain it because I think it's a brilliant idea.
Well, I mean, what guides us is we're trying to be, I call it the 3Ds, which is decentralization, decarbonisation, and democratization of energy. Okay, or fairer, faster, and more flexible, if you like.
It's always good to have things in threes, right? And it's a 3TI, so it goes along with the name of the company. Before actually we move on, I have to ask: is it just a UK product, or is it available in Europe and potentially in the US in the future or whatever?
So at the moment, it's just in the UK, but obviously, from the nature of the project, it internationalizes quite well. So absolutely in the future, we'd look to internationalize the product. It solves the same problem in lots of different territories. It's not something that we would manufacture in the UK and then, ship overseas. That doesn't really make sense, not least from a carbon perspective. But, ultimately the technologies that go in there can get, delivered anywhere in the world. The skills required to build it can exist anywhere in the world. Fabricators, machine shops to do the physical part of it. And then essentially we would put our magic in a box that makes it all work.
Let's talk about CCS. I don't know how long you've been driving EVs yourself, but my first EV was a Nissan Leaf, and it had a CHAdeMO plug, obviously. And I remember it being super easy. You just plug in, it worked flawlessly. There's no complexity in like negotiating stuff or whatever. It never failed. And then I would hear from other people who had CCS cars like i3, what was the other one? The Ionics, the early Ionics. They had problems with CCS. It would work about half the time, and I always wondered why is it there a problem? Talking to other people in the past, because I don't have access to the CCS spec. Obviously, you have to pay for it, and then they're trying to keep it secret for whatever reason. I don't know. Same thing with CHAdeMO, but CHAdeMO apparently is just a CAN bus, simple conversation. It's probably encrypted these days, or there's some sort of a verification, but it's quick. There's no negotiations, whatever. From what I've heard, and I don't have a spec, I've never read it, so I have no idea exactly like the details. But there's multiple layers to it, and multiple negotiations, loads of certificates sent back and forth, and some things about payment, obviously, that have to be verified and signed by an external API. And so you're waiting for all that to happen over like 4G network that might not work all the time. And that's why it takes longer, or it sometimes cuts out. And obviously, being a spec, a committee wrote it, and different people will implement it differently because there's some differences. I don't know if there's a reference. So when you design a spec, sometimes you have a reference source code or like reference implementation. That's the word I was looking for. That makes it easier because you can just test it against reference implementation. If it works for a reference implementation, that means you're good. And why do you think CCS is so complex? And is there a way to improve it? And should we be worried that it's so complex?
So CHAdeMO uses a CAN bus, the same type of communication network that runs across the vehicle. It's well understood within the automotive industry for a start. It's quite robust and it's quite simple. CCS essentially uses Powerline Ethernet. It's using a full IP stack. And the standards don't just define how it should work. It's got lots of different options, and lots of different services. And some of those services aren't defined yet. Some of them are more been recently defined, like the bidirectional capabilities within the Dash 20 spec. And so what you've got is an inherently much more sophisticated communication stack. And it's been developed by committee in a very, really frankly, slow process, which has taken a very long time. And it has resulted arguably in a far superior specification. But, I think you've probably hit the nail on the head, which is if you don't have like a reference design, a reference model, a kind of a clear test case of what it must do and how it must perform, then you're left with lots of people trying to work it out for themselves. And, and what I was saying earlier about, a lot of standards are good at defining the language, but not necessarily the conversation. And some of the timing specifics and some of the kind of, what if things go wrong characteristics. This is something that kind of tends to dog a lot of standards, is that they define how language it should speak. They don't define the conversation. And more specifically, when something does go wrong, how should either system respond? So everybody makes their own decisions. So then you end up with this compatibility problem where you've got different parties having to essentially test each charger implementation on each vehicle implementation. And it's another N squared problem. It gets very complicated very, very quickly.
You're an engineer as well. In the end, people think that complexities add, but they actually multiply. That's why when you say N squared, I know this is something that people don't realize, that the two problems actually is, or three problems is not just three times, it's nine. So, but like I say, CCS has a lot of complexity because they were trying to be forward thinking, right? It's more of a RS-232 versus USB, if you like that analogy. And USB allows you to have multiple types of hosts on the same connector, right? That's why you have hubs and stuff. But that means that a USB microphone can be also a headphone amplifier, because you can have two functions. Or a keyboard could be also a mouse controller, right? Or whatever. With it, there's a lot of complexity. But USB as a standard is open, and there's loads of reference implementations. So
yeah. But then, there were early USB compatibility issues. But, to me, CCS hasn't got that early excuse anymore. It's been going for such a long time that there shouldn't really be that excuse for that. Now, one of the things which has also made it complicated is really motivations, right? The people who are developing the specifications, everybody wants a slice of the pie. An OEM is a typical problem. They're used to getting a lot of after sales service in combustion engine vehicles with filter replacements and spare parts. In the EV world, there isn't quite so much maintenance requirement, pollen filter or something like that, but it hasn't got the same aftermarket kind of income. So OEMs have been looking at ways to potentially get more through life income from a vehicle. So they're absolutely dead keen to own some of the money stacks. So the whole 15118-20, a lot of the delays getting that agreed was really OEMs want to own the payment processing, and things like grid services, they want to own that themselves. Some of the OEMs actually setting up virtual power plants at the moment as a way to provide grid services, flexing their customers' vehicles. And that's kind of planning ahead, if you want to call it. That land grab really is one of the things that's really slowed it down. And that's put things like bidirectional charging with CCS vehicles, it's put it a decade behind where CHAdeMO vehicles are.
I always get asked not always, but I get often asked about the vehicles to load and vehicles to grid. And I'm in two minds about it personally, but CCS does have a provision for it now, right? It's just the cars don't seem to implement it. OEMs are dragging their feet. I don't know what's happening. Like I have a Kia Niro EV, the new one, the facelift one, and it's got a plug in the back couch, and it's got a vehicle to load provisions. And I was told through back channels that they've designed these vehicles from ground up to actually be bi-directional. That's why they're putting plugs in them, all of them, because it already has that capability. It could power your house at like 32 amps apparently, if they enabled it for the software. Like the hardware is there. but it's the lack of agreement or maybe political dragging of feet and, land grabbing, like say.
Yeah, it's complicated, and I don't know how much detail you want to go into, but I know quite a lot about that. So there are two. First thing to separate in your mind is the type of V2X. Okay, so we understand V2L, which is essentially grid forming. You're creating a little sort of 50 hertz signal that you can plug your kettle into in the back of your car. Now that's quite different to being grid connected, because grid forming versus grid syncing means that you've got to have hardware that synchronizes with the grid and can export AC to the grid. Now there's two ways of doing that. One is that you take the power out of the vehicle in AC directly using that V2L type function, but having it synchronizing with a live grid at the same time. Now there's lots of complexities in doing that, and you probably don't want me to go into them, but from grid regulations, grid code, safety, earthing systems, disconnects, islanding, the whole bunch of challenges, making that safe, making it regulatory compliant. And it's absolutely the way that the mass market bidirectional capability needs to come out, because it will work in residential with relatively low costs of all hardware, but it's immensely complicated. Having export, the vehicle is actually controlling what exports to the grid. The ability, these things you may have heard of, G98, G99, or even G100 export limitations to grid, which is there for safety and for lots of complicated reasons with distributed energy. These codes are very hard to meet if you've got a vehicle in control of it, unless you've got specialist infrastructure. So the direction that I think needs to happen in the near term is that you look at DC export from the vehicle, which is what CHAdeMO and CCS do, right? So you've taking DC out of the vehicle, doesn't need anything extra on the vehicle. It doesn't need additional V2L hardware. It doesn't need isolation. It doesn't need lots of extra software that can work out where it is and whether that location's got an export agreement or any of those sort of infrastructure level complexities, because the infrastructure does it for you. So if you put a charger on the wall that takes DC out of your car, that charger on the wall makes sure that the installation is compliant.
And then you don't care as a OEM about the differences between regulations in each country as well, right?
Yeah, and so it's very, very much simpler from the OEM's perspective. All they need to do is enable software to let you take power out of the battery, and nothing else is essentially free. There's no hardware upgrade cost. And obviously OEMs are very reluctant to invest in that hardware on the vehicle and the software to support that AC export from the vehicle, because it's an uncertain market at the moment. And they can't upsell that to their customer as, pay an extra £500 and get this capability if they don't know that capability is going to work, because those codes, those regulations, those complexities aren't resolved yet. And the business case for supporting that could still be a number of years away. Now, to me, the only way to get the data to support the business case is to start doing it. So this is the kind of catch-22 we're in at the moment. The OEMs don't want to put the hardware on the vehicle because they don't know the business case is there, and we can't get the business case because there's no hardware on the vehicle.
Do you think, I often hear people like, the market's going to take care of itself, and as much as I would like to be an optimist about marketplaces, I'm an engineer, I'm a pessimist and cynic by nature, because you have to be when you're working with hardware, right? So I always say to people, the marketplace is great, but we have regulation because it doesn't work 100%. So do you think I don't think it's going to happen, but if a country X said in their regulations, okay, all the new EVs with CCS plug have to have a DC vehicle to X, integration by standard, like it's a requirement to sell your vehicles in this country to register them. Do you think that would help?
Absolutely. Absolutely, 100%. And that is absolutely something we must do. Okay. There is no excuse from the OEMs not to do it. Okay. OEMs love AC because they get to own the revenue stack and they get to decide how much of the slice of the pie they take and how much to give to their customer. With infrastructure side, the infrastructure chooses. So that the challenge for OEMs with DC is they don't get to control, which slice of the cake people get to eat. Okay. And that's why one of the reasons they're probably quite reluctant to do it. But actually, I would like to go even further. I'd like to make it mandatory to deploy DC V2X on all the existing CCS vehicles.
Do you think they're all capable? Because at the end of the day, the two prongs at the bottom of your CCS, whether it's one or two, US versus Europe.
Right. There's a pair of contactors sat behind that connects you to the battery.
Yeah. Unless you're Tesla, in which case you have two probably. I think they have a bit more complexity behind it for, I don't know what.
Well, on the ones where they share the pins, they do, yeah. But the bottom line is that there are 2 pins which connect to the external charger, whether it's CHAdeMO or CCS, that has got essentially a direct connection to the battery. The only thing required to enable DC export from those 2 pins is software from the BMS, from the battery management system, kind of configured from the vehicle that says you can have this much power, my minimum acceptable state of charge is this, my maximum desired state of charge is this, and in fact, the infrastructure can do a lot of that already. So it's really just making sure you haven't got the software in the vehicle. It's actually almost removing a piece of software from the vehicle. The piece of software in the vehicle says, hang on, if power's going the wrong way, shut off those contactors, something's gone wrong. Okay, I'll take that line of code out, and then you've got DCC V2X, and now you've already got much higher market saturation of vehicles, because the only way that V2X is going to work is with a lot of vehicles with support for bidirectional. Making it a requirement for those to enable export would instantly increase the number of available vehicles.
Do you think we need a open source like Linux revolution in the OEM industry? I mean, I know for a fact, because I chaired a conversation at a Move conference last year where there were 2 ladies talking about, experiences in OEM as an OEM employee, essentially. And one of them is, I can't remember exactly her title, but she works for a startup called the Vehicle, just funny spelled vehicle, where they're doing essentially that. They're trying to develop an open source platform so that the OEMs could just take their existing software and build up on it. I think not that I don't like what they're doing, but I think we need more attempts at that. Obviously, Linux was easy because a bloke just wrote his own kernel back in a day when operating systems weren't as complex as they are now. And, that kind of sparked the thing. Cars are way, way more complex. So you can't just have a bloke writing a software for the whole car in his garage. What I'm thinking about is basically if there was a common platform that all OEMs had to adopt, that would give that, everybody talks to each other and it's a known entity.
Yeah, I mean, there has been attempts to do that in automotive. So there's a organization called AutoSAR, which has essentially tried to create a common RTOS, real-time operating system, on which at a vehicle level, if you choose to implement all the layers of it, at a vehicle level, you can kind of choose where your code lands. So it's going to sound a bit strange, but you could have your cabin heater control software running on your window winder motor embedded controller. It's like that. So they have had an attempt at doing that. Now it's a proprietary organization. It's not quite open source, but it's common standards. And once you pay the license fees and once you're into the cool club, if you like, then you have the ability to do that. Very few people have implemented that across the full stack because it's a very expensive thing to do, and it does create a lot of challenges. But another way to look at it is what happens if you don't? So what happens if you don't is you end up spending a lot of time and a lot of money developing something that, kind of copies what somebody else has done. And that makes it very inefficient. So you've got those engineers are going to be paid for somewhere, somehow. So it becomes a very, going open source, as we've seen with Linux, enables the industry to progress very, very much faster, but at the cost of how do I monetize this specifically for me? If we're going to put that engineering effort in, how are we going to make this money work for me? So, I kind of understand both sides of the argument. One of the things I would point out is that there are certain suppliers like Bosch and Conti are kind of within the ABS market. If you want to use one of their systems, you have to work the way they want to work. If you're an OEM, you don't really get to control how that system works because they are the experts in that. You make your system work with them. So it's actually, some of it's not even in the OEM's control. And one of the things I found really interesting, I worked in China quite a lot. And one of the things I found really interesting in China is that the Chinese government have essentially put in place standards really quite early on to make Chinese vehicles, or more specifically the component manufacturers of Chinese vehicles, use a common protocol stack, which actually is part of the reason the automotive industry, and especially the electric vehicle industry, has accelerated so quickly over there, because they have got common standards that other manufacturers are using. And now you've got an integration job, not develop the software, define the software, and everybody doing the same thing, which is just incredibly wasteful.
Yeah, I mean, just going back to the, how do you monetize it? At the end of the day, software is harder to monetize than hardware, right? Because when you sell the car, you can put a price tag on it. Doesn't matter if parts of it are open source or not. You still have to sell that hardware, right? And you differentiate yourself because it's a nice plush interior or whatever. There's other things that people care about other than just geeky stuff like we do.
Yeah, and remember the OEMs. What they used to do was stamp metal and stick metal together. Okay, what they're doing now is they're becoming these vehicles are very sophisticated computers driving around with very sophisticated electronics on them, and the bit of stamping metal and sticking it together is not really where the optimizations are anymore. That and that's where the OEMs are coming from. Of course, they're coming from, can they make it better quality, and create those brand positions that meet those driver experience needs? Can they get the right suspension? It's a very different world to being a software defined platform. Now, as we've seen, Hyundai, Kia, we've seen consortiums, Stellantis, these consortiums now working together, going, actually, we need to commonize this. So it's not quite to the point of open source, but it's not that far off in as much as you've now got common platforms across multiple vehicles, which is why you've got this consolidation happening where, we've got 5 vehicles which are all common platform behind them, the same software stack, the same communications that you've done your testing, your validation. Once when you send a software update out, you're sending it to 5 different vehicle models at once. So it's kind of heading that way. It's not quite to the point of open source.
I don't think it will ever be, but I think, again, it's good to know that things are happening. It's not as terrible as it seems from the outside. You know what I mean?
No, well, the Kias and the Hyundai, they're the same vehicle, right? Yes. Yeah. Well, but a lot of you've got Volkswagen and Audi Group, the Stellantis. These got a lot of brands are owned by one company, and the platforms that they're running on are a common platform. So Volkswagen were doing this a decade ago, where they realised that actually your Golf, your Passat, these are the Polo, these, especially with the electric versions of them, having a common platform makes perfect sense for those. To the point where even on mechanical engineering, they're just putting a different body on it, but the wheels are the same distance apart and everything else fits.
ICE cars are even more integrated, right? There's fewer differences other than the shape on the outside and the interior between ICE cars, even from different manufacturers, because they take the same components from Bosch, Siemens, and there's probably like 3 of them in the whole world, right?
Absolutely. And I remember, this is going way back now, when my first car, the starter motor for the Ford Fiesta was the same starter motor that the Ford Mondeo had. And I remember breaking down in France one time with a Vauxhall I had, and we ended up getting the replacement part from Peugeot garage because it was the same part. So it's kind of, it's been there in the metal bashing world, and obviously it makes sense when you're putting tooling together to make an exhaust pipe a particular shape. Or having to change the shape of your exhaust pipe for every different model you come out with is quite an expensive thing to do because you haven't got those economies of scale. So it's kind of existed at the mechanical level for quite some time, but scaling that up to the software level is kind of what's going on right now, because the metal part of it has become quite commoditized. So now you try and differentiate yourself in the software. And then you've got things like Android Auto and CarPlay, which are actually taking some of the user interface, user experience elements away. And that's, so there's lots of complexities coming in the automotive world for sure.
There's a lot of, worry about people charging at night and, being assaulted or whatever, or other problems, and they just want to get away fast. And not negating people's needs to have to feel safe, because that's just I think there's a lot of work that still needs to be done to ensure that the charging points are safe. Unlike petrol stations, they don't have usually staff on site to call the police or CCS, a massive canopy and loads of lights. These things just are lit all night long sometimes, and it's crazy. But to me, it's also quite crazy, the idea of being able to just drive away with the charger attached or the plug just snapping off if you needed to escape. Because I just look up the videos of people driving away with the pump still plugged into the thing. I don't know. What are your views on CCS safety and these sort of things and solutions to that?
Well, let's start with the first bit there, which is about charging safety. Okay, so you've probably heard of a company called ChargeSafe. Kate Tyrrell, in fact, she was here yesterday. I don't know if she's here today.
Yes, yeah, Kate, yeah.
It was actually my hometown, Farnham, where she had a terrible charging experience, which is why she kind of started that company. So I've been in touch with her. So we've made sure that our solutions are, we've got CCTV, we've got lighting. In fact, we take it a bit further than that. Our lighting is battery backed. So even if the grid power goes out, we've still got battery backed lighting, making sure that you're not tripping over your cables or coming back to a dark puddle in the car park. Okay. And I think the solution is to make your charging safer to start off with. The technical side of this kind of ability to drive off with your car connected, as an emergency thing. Well, first of all, there's regulatory requirements as you can't. UNEC R100 specifically tells you that your vehicle mustn't be able to drive while it's connected to the infrastructure. The safety concern associated with that, I think, is probably a little bit misplaced. There are lots of other ways to disable a vehicle from driving, whether it's plugged into the infrastructure or not. Okay, most EPBs, most EVs, in fact, most ICE vehicles now have got EPBs in them. You just go and unplug the EPB caliper at the back. That vehicle's not going anywhere. If you want to stop that vehicle from moving, go and park in front of it. Let its tyres down. Stick a pole through the alloy wheels. There's a dozen ways to stop a vehicle from moving, and the charging infrastructure is just one of those ways that the vehicle doesn't move. In fact, you could even disable a vehicle by not having it plugged into the charging infrastructure and emulating a vehicle cable being plugged into it. Okay, it's that idea of being able to drive off with a cable connected as a safety thing. Well, make your chargers safer to start off with, and recognize that is just one of many ways that a vehicle could be disabled from moving. The charging infrastructure should be in a safe place to start off with. That's what, Kate's campaign is about. Exactly. And it's exactly the right campaign.
Yeah, I think we were both in agreement. Better CCTV, and if somebody wanted to attack you, they have other ways to stop you from driving or moving away.
So many other ways. And it's not unique to EV. To me, it's a little bit of scaremongering. Okay. And you see this like with, EV fires. Okay. You kind of get these companies creating solutions to problems that don't exist. And then the entire marketing campaign is really about creating the problem, the perception of a problem.
Yeah, it reiterates something that's not a problem really in the grand scheme of things, but actually people think, because it's a solution, all of a sudden it must be a real problem.
Exactly. So you look at this EV fire, stuff that you see, the FUD, the fear, uncertainty, and doubt that's being cast. Okay. When you actually go and look at the sources of it, it's one of two sources. One is, fossil fuel industry or, papers or whatever sponsored by a fossil fuel industry. And the other is people touting solutions for, car park EV fire suppression or electric fire suppression blankets for electric vehicles. These are they're creating the market, this perception of a need for something that actually there's no statistical evidence or even a burden of proof.
What data do you know? Or somebody said to us, we should be aware of it. I was like, okay, but you're a professional. You should know more about these things than I do.
And the stats doesn't support it. If you want to ban vehicles from multi-story car parks, ban the ones that catch fire the most. That's the combustion cars. Oh yeah,
diesel ones. Luton fire was one of those examples where everyone's like, "Oh, I'm sure it's a battery-powered vehicle." It was turned out it was a Land Rover that had a leaky diesel, pipe. So
no, and it happens all the time. But it's not headline news, is it? So, and that's kind of what frustrates me a little bit is these companies. They're kind of it's amoral to go and create fear in the hearts of people who feel vulnerable, to tout their solution to a problem which doesn't really exist, or arguably exists in so many other forms. That one solution isn't going to solve it.
Yep, I fully agree. Mark, anything you want to say on the way out?
Well, thanks for having me here. It's I wasn't expecting it this morning, but it's nice, very nice to do so.
Thank you, Mark, and everyone should check out the 3TI. I'll put the links down in the description, and thank you for listening.